Alright, so in this video we're going to do 10.5. Welcome back. This is 10.5 in chapter 10, so we're finishing up our probability chapter now. We're getting to the end. We've spent a few sections looking at different ways to calculate probabilities in different contexts. And now we're going to do something slightly different, and this is called counting. So probability relies on us counting really well, right? We need to be able to know how many outcomes there are and how many outcomes were possible, because that's how we calculate a probability. We need to be able to figure out that number to be able to divide it. And so this section is really going to go over how to count, which sounds really simple, but sometimes counting gets complicated in probabilities, right? You got to think of every single possibility of an event happening. So we're going to go through a few ideas about how to count things. So the first thing is the general multiplication principle. So this is kind of the stuff that we've been doing, but this is like the official word for it. So let's start off with something simple. We have a coin that's flipped 2 times. What are all the possible outcomes? There are a few different ways I can do this. I could just kind of go through it, right? It's only 2 coin flips. That's pretty easy for me to just write out. So if I flip a coin once, I could get heads, and I could get heads again. I could get heads and then tails. I could get tails then heads, or I can get tails and tails. I have those 4 outcomes. So that's one way I can do it, but this might not be the best way to make sure, like if I had like 10 coin flips, maybe, who knows, I might miss something. The other way we've seen is using a tree diagram. So I start off flipping 1 coin. I either get heads or tails, and then I flip my second coin, which gives me heads or tails again, and then I read down the tree, so I get heads heads, I get heads tails, I get tails heads, and I get tails tails. So I get the same thing I got in the first one, but this way it's probably just making sure that I don't forget anything. The other way I can do this, and this is what we're going to build up to, is the tree. So first of all, the tree diagram is great. If you can use a tree diagram for something, I would use it. The tree diagram, though, suffers from space, right? So like if we're looking at really big things, drawing out that tree diagram can get really cluttered. Supposing I have like 10 different things that could happen after this, or even like that first problem we did where it was flipping a coin and then rolling a dice. After I flip a coin, I have 6 different things to spoke out of this. That's just not going to fit really nicely. It's going to be really hard for me to manage space on to write it. And then as those events get bigger and bigger and more things are happening, it's just not going to be feasible for me to draw this out each time. And so now we want to generalize this, right? Think of ways, what is this tree diagram actually showing us? And then try to generalize that to something that we don't have to draw the tree diagram for. Now in my head, I'm still thinking of the tree diagram when I do this. And if it helps, I would highly encourage you to still draw the tree diagram. But let's think about what's going on here. I have 2 things happening, right? I'm flipping a coin 1 time, and then I'm flipping a coin a second time. The first time I flip it, I have 2 options. I either get heads or I get tails. I'm going to write it 2. The second time I flip it, I again have 2 options. I can either get heads or I can get tails. And then what I'm going to do is once I write down just those individual, like how many possibilities I have for those small events, I'm just going to multiply this across. I go 2 times 2, and I get 4. That helps me count it. So now this is important with this principle, right? This doesn't tell me what those outcomes are. It doesn't tell me it's heads, 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 tails, tails, heads, and tails, tails. To do that, I still have to do the tree diagram, or I have to make a table, just list everything out. But if I just want to know how many there are, I can use this to just know there are 4. Now what those 4 are, I don't know. I'd have to do more work to find that. But I can know there are 4. And for calculating probability, you just need to know how many there are. You don't need to know what all of them are. So let's do one more example. So we have a 4-digit combination lock that has certain requirements. The first digit can be 1 through 9. The second and third digits can be 0 through 9, and the last digit can only be an alphabet. So we have 4 digits in this lock. So I'm going to put 4 blanks. Now for the first digit, it can be any number from 1 through 9. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 options there. So I'm going to write down a 9. For the second and third digit, I can go 0 through 9. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 options. So I have 10 options for the second digit, and I have 10 options for the third digit. So I'm just writing down how many options I have for each of those spots. The last digit can only be an alphabet. Well, there are 26 alphabets. I'm just going to put a 26 down there. Once I have all those individual options listed out, I'm just going to multiply it. So this is an example of the tree diagram becoming really big. If I made a tree diagram for it, I would have to go 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then from each of these options, I have 0, 1, 2, 3, 4, and so on. And then from each of those, I again have 0, 1, 2, 3, and so on. And then I have A, B, C, and so on. So you can see how the tree diagram would get really complicated. I can't fit that in here, nor do I want to take the time to write all of that out. But condensing it to just the numbers, I had 9 things here. So I put the 9 over here. I had 10 things that come out of it. So that goes there. I have another 10 things, so that goes there. And I have 26 options after that, that goes there. Then I just typed it all into my calculator to multiply it out. So I go 9 times 10 times 10 times 26, and I get 23,400. Right, so imagine if I had to list that out, make a table, or make a tree diagram, I would end up with 23,400 things in the end. I don't have space for that. I don't have time for that. So this is going to be much quicker. So let's do one more option, one more example. So now we have a 5-digit passcode that can use any digit from 0 to 9 for each entry. But once we use a number, we can't use it again. So 5 digits, so I'm going to set this up with 5. And I can use 0 through 9, so that's 10 options for the first digit. Now once I use a digit, I can't use it again, which means whichever number I chose for the first digit, it goes away, right? So here I can use 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. For the next digit, whatever number I chose here, so let's just say the first digit was a 4. The next time, I can only use 0, 1, 2, 3, 5, 6, 7, 8, 9. So now I only have 9 options. Then whatever number I choose here, that goes away, so then I only have 8 options. Then I only have 7 options. Then I only have 6 options. So this limits the possibilities, right? Because it's not letting me repeat, so those numbers are going down each time. And then I do the same thing. I multiply this all out. I go 10 times 9 times 8 times 7 times 6. And there are 30,240 possibilities. So I want you to do a practice problem like this. So this is a restaurant that offers a fixed price dinner menu. So that means you can get one item from each course, and you pay $30. You can choose any of them, but just one from each column. So you have a first course, you can get a salad, tomato soup, or French onion soup. For the second course, you can get a burger, grilled shrimp, mushroom risotto, and ravioli. For the third course, you can get a cheesecake or an ice cream sundae. So you want to know what are all the different possible meals you could order? What are all those mixtures of things you can get from each of these sections? So pause the video, try this out on your own, think about how many possibilities there are, multiply it out, do that stuff, pause it, do that problem. Okay, so now you should have done that problem, and I'll show you how to do it so you can check. So here we have 3 different courses. So we have 3 different openings we can fill with food. The first course, we have 3 different options. The second course, we have 4 different options. And the last course, we have 2 different options. So then I multiply that all out, I get 24 meals possibilities. And there are 24 different ways I can choose things from each section to get a different meal. So that's our basic counting. I'm going to split these videos up into chunks so they're not like super long videos. So I'm going to stop this video here. That's our basic counting principle. And I'll make another video going into the next thing with counting.